Hello, I'm Anna Mackay, and have you got problems? Well, I can help you solve them, provided that they're about quadratics. So that's what we're doing today. A bit of a refresher, talking about some of the reasonableness of some answers that you might get. Things to remember, if you're finding a length of something and you get a negative answer, two things: you might have done something wrong, or if you've got two x answers, you might need to reject the negative solution and make sure you take the positive answer. And if you have a question about perhaps how many people are present at something, then you must always have a positive integer. You can't have half a person, so you must round to the nearest positive integer if that's the case. Just some basic steps here. If the information is given in words, you need to extract out of that an equation. Also, if they give it to you in words, you must answer in words at the end. So you write down your equation, you choose a suitable method of solving. It could be factorising, occasionally completing the square, quadratic formula, graphing, technology, those sorts of things. Check which solutions are acceptable. Again, going back to those point about you can't have a negative measurement, and then answer in a question. All right, let's do a couple. So you've been told that a rectangle. So before you do anything, picture that rectangle. It has length, so the length side, 3 centimetres longer than its width, and its area is 42 centimetres squared. And we're asked to find the width of the rectangle. So I would start by drawing a shape, and not just any shape, draw a rectangle. And you might be interested to know, well, which one's going to be x? There's always going to be an unknown. Look at what it's asking you to find. And often the words that follow after that give you that clue. Find the width. So I would make the width x. We need to create an expression for the length. And here it told us that the length is 3 centimetres longer. So 3 more than x makes it x plus 3. And its area is 42 centimetres squared. So we can create an area expression now. If area is length times by width, we have here our x. It doesn't matter if we go width times by length, that doesn't matter because multiplication is commutative. So we can shuffle them around like that, is equal to 42. And so there's our equation, and we need that to expand the brackets and solve for x. So we have x squared plus 3x, bring the 42 over, is equal to 0. Now you need to solve for x. You could look for factors of 42, but when in doubt, the quadratic formula will always work. So it's x equals, don't just write equals, that we have our a, our b and our c. Some people find it really handy to identify what those are. A is 1, the coefficient of x squared, b would be 3, and c would be negative 42. Make sure you take account of those signs. So the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times by c. And then I finish off my square root all over 2 times by a. Working that out, keep your x equals there, negative 3 plus or minus, I can tell you that that comes out to be 177 over 2. So our two answers here is you'd need to calculate this. One is with the positive version of the square root and one is with the negative version. So your two answers are approximately equal to, or you could do equals like that, 5.15 or negative 8.15. And you must identify the fact that you can't have the negative answer, and something along the lines of but x is greater than 0 implies that you know that we're dealing with a length, a measurement here, and so therefore you're going to choose this answer. But read the question. It's asking you to find the width. So answer with those words. Therefore, the width is what? Is $5.15? No, centimetres. So that's how we answer that question. Second, is it possible to bend a 12 centimetre length of wire? So start to picture what that would look like. So we're bending it to form the perpendicular sides. So you've got this wire and you're going to bend it, I haven't used my hands very well there, of a right angled triangle. So you've got two sides and you have to picture what the triangle would look like that has an area of 20 centimetres. So there's no right or wrong way to visualise this. What I did is I visualised a 12 centimetre length and then I'm imagining it bent. So perhaps if you bent it like that, and they are the perpendicular sides, so they meet at right angles, of a right angled triangle. So there would be our right angled triangle with area of what? 20 centimetres. So therefore we need some information about the side lengths. So identify X. My suggestion is pick X here for this shorter side, and then what would this length be? Well, the length of the whole wire is 12 centimetres and you've used up X, so it's what's left over. It's 12 take away X. And visually on this wire here, perhaps that would be X, and therefore 12 take X is that part there. Now how's that going to help us? We need the area of a triangle and make that equal to 20 centimetres. So we have area is equal to a half times length times width. So we have a half of X and 12 take X. And we know that that's equal to 20. So we're going to do some rearranging to solve for X here. My first suggestion is to multiply through by that half to get a 40 over here and expand the brackets. So we have 12x take x squared. Rearrange to have descending powers of x, but my other tip is have a leading positive coefficient of x, not a leading negative. So not only am I going to rearrange, I'll just show you what I'm doing here. I'm going to make the right hand side 0. If I bring that 40 over, it would become a negative 40, but because I'm going to multiply through by the negative 1, it's now a positive 40, and we have a negative 12 there. I've probably done 2 steps in one go, but I'm sure you can cope. Again, you could try factorising or using quadratic formula, using the quadratic formula. So we have minus b plus or minus the square root of b squared. Now it's negative 12, all squared there, plus, minus 4ac. So there are our numbers there, all over 2 times by a. Now if you work that out, the component under the square root sign comes out to be 144 subtract 160. So what type of number is that going to give us? That's going to give us negative. So this part here, we would say the discriminant is equal to negative 16. So that makes it less than 0. Now what do we know? That when the discriminant is less than 0, what type of solutions are there? There are no real solutions. So in the context of this question, we would write, obviously underneath, but I'm running out of room, no real solutions. So go back and read the question. Is it possible to bend a 12 centimetre length of wire to form these requirements? No. Therefore, not possible. And you could add something like with these conditions or something like that. Okay, so that's 2 examples of problem solving with quadratics. The next one is on 2H quadratic optimization. Subscribe to the channel and tell your friends. Thank you.